Welcome back to Algebra 1, Chapter 10, Section 1 in this book, Adding and Subtracting Polynomials. Now, this is a little bit a word thing, and then one easy skill we're going to learn. So, poly means many, nom comes from name, but what it means is it goes back to that idea you cannot add and subtract these things in algebra unless they have the same letters with the same exponents. So these all can't be added together. We just put pluses or minuses between them and that's what it is. This whole thing is a polynomial because it's made out of 4 terms. Each of these things is called a term. Now for this polynomial, this is called a third degree polynomial because the biggest exponent that goes with the letter is 3. The proper way to do it, the math etiquette, is you put them in order of the exponents of x going down. So we have 3, 2, understood 1, none. Okay, so this is called standard form. It's where you put all these terms on one side, and on the other side you have y, 0, f of x. Remember, weirdly, they're all sort of the same thing. And or it might be gone all together. All right? And so this is called standard form, and you put them in descending order of exponents of x. The number that goes in front of the letter is called the coefficient. The number that goes with the one with the highest exponent is called the leading coefficient. The number that has no letter is called the constant term sometimes. Sometimes we change up names depending on what book it is. So I just call it the bare number. That reminds me, this one has no letters, it's the bare number. Alright? If there's just one term that is not really a polynomial, it's called a monomial. If it has 2 terms, it's called a binomial. 3 terms is a trinomial. More than that, it's just called a polynomial. But in real life, nobody uses these. You just call them polynomials. And it's when you have more than one term. It usually gets called a polynomial. Just one of those little nitpicky things they teach you and then you can just kind of forget. Because really, just remember what a polynomial is. It's where you have these terms connected with adding and subtracting that can't really be added or subtracted because they don't have the same letters with the same exponents. Okay? Next idea. If your polynomial, the biggest exponent it has is an understood 1, like if that's our polynomial, if we graphed it, it would make a line. It's linear. If it has squared in it and we graphed it, it's called quadratic and it'd make the parabola. If it's got to the 3rd power in it, like this one, it's called cubic. If you graphed it, it looks like this. One arm, one up, one down. And to the 4th power is called quartic. And it kind of looks like a W. If it's positive in front of this, it goes up. If it's negative, it turns down. Same thing with the parabola. If there's a negative sign in front of this, it turns down. Instead of being a U, it's a hill. All right. Some of that's more important than others. Okay, this is our skill. Adding and subtracting polynomials. Now, I used to try to get the students to do adding and subtracting up and down, multiplying and going out. But really, in real life algebra, you usually don't bother rewriting up and down. So I'm going to teach you the big boy and girl way to do it, where we're not going to bother lining them up vertically. We're just going to do it the real way, horizontally. Okay, so how you add these up is you sing a song. Gathering up your terms and the dance, stowing away the time, it's 2 on each side. Alright, now, one of my kids' professors at Chattahoochee Tech said to do them in different colors. I think the different colors are unnecessary if you follow my method of circling it and marking it off. I'll show you what I mean. Alright, so I'm going to add these up. If they're all adding all I have to do is look for the biggest exponent. That one's a 3, and there's a 3. I find my biggest exponent terms and circle them. I have 1, 3 there, and 1 to the 3rd power there. Then I do the math on them. 5x cubed minus 1x cubed is 4x cubed. Then I mark them out. I think that pen's kind of dying. Let's switch to black. You know, green's real good. Let's do green. Okay. Now I am doing different colors, just like the Chattahoochee professor says. Okay, now I'm going to look for the next one down, which is squared. And I circle it with its plus or minus sign. There's one right there. Ooh. Okay. So now I'm going to gather them up. I have plus 2x squared. This plus goes with that. So 2 plus 3 is 5. Plus 4 more is 9. So it's plus 9x squared. Mark them off. Okay? Now the next one would be x's. So I'm going to circle them. There's a negative x. Go along and find them. There's another one. Uh-oh, I ran into my 7. Okay. So I've got negative 1x minus 4x is negative 5x. Mark those out. And now for my bare numbers. 7 plus 7. See, I marked through. I almost messed it up. 7 plus 7 is 14. Minus 8 is 6. Ta-da! That's how you do it. Okay? Let's do it again. So first we look for it's plus, so we just look for our biggest exponent, which this time is a 2, and circle it. 2x plus squared plus 1x squared is 3x squared. Mark them out. Chink, chink. It's more fun with sound effects. Okay, now we're going to do the x's. There's an x, and there's an x. X plus x is 2x. Chink, chink, mark them out. Negative 5 plus 6 is 1. Chink, chink, mark them out. Ta-da! Yay, we did it. Okay, now what if it's minus? If it's minus, you have to distribute that negative to all the term after it. It's like the distributive property with the understood negative 1. So I write down the first one as is, and now I'm going to do it. Negative times negative makes a positive, 2x cubed. Negative times positive is a negative 3x, and negative is positive 4x. Now, I can just do it. Gathering up my terms, look for the biggest exponent, is to the 3rd power, and look, those cancel each other out. 2x cubed minus 2x cubed, there aren't any other x cubes, those go away. Okay, now let's do the squareds. Any other squareds? No. So 5x squared is the first one. Now our x's. Negative x minus 3x is negative 4x. Mark them out. 8 plus 4 is 12. So see, that's not bad. Same thing here. I distributed my negative, making that, is that right? Negative 7x. And negative 4x squared. I gotta make sure I wrote down the right problem. Since, yeah, I did. I just did it wrong. Alright, so now we're going to gather up our terms. X squared minus 4x is negative 3x squared. Mark them out. Minus 7x. Mark it out. Minus 8. Mark it out. Okay, here's another one. There's the first term. I distributed the negative. Negative, wait a minute. Make sure I wrote down the problem right. Yes, that's a positive there. It's hard to tell because that's my arrow. So it's negative 2x squared. A negative and a negative makes a positive x. A negative and a negative makes a plus 4. Look for the biggest term. It's squared. Okay. 3x squared minus 2x squared is x squared. Mark them out. Negative 5x is x is next. Negative 5x plus x is negative 4x. Mark them out. 3 plus 4 is 7. So you can do different colors if you want. What the Chattahoochee guy, the professor said, was when you circle them, he said to circle them in different colors of pen. That takes too much time for me. I just like to circle them. But if you're like really into colored pens and pencils and all that, this might be what you want. My son Nathan does it. He's got his little pack of billion different colors of pen, and he does it that way. And you will use this skill from now on, all the way through calculus. So this one's really important. Put the flashing lights around it. Woo, 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 woo. And remember it forever. Some of these terms aren't all that important. You need to know polynomial. You need to know leading coefficient. You need to know degree. You need to know term. You need to know polynomial. You need to know that that's linear, that that's quadratic, and the other stuff, you'll get more of it later, but that's sort of it. So I think this is really fun. What I have to be careful with is leaving no term behind. If I'm going to mess up, it's because I'm going to leave something behind, and that's why I have to circle it and mark it out. No man left behind. No term left behind. All right? So have fun with this, be organized, and it's really easy. This will be on the SAT, the ACT, and your college entrance exams, and in your college algebra class. So make sure this one makes sense, all right? Math is great. See you next time.